Well, we're going to talk about confidence intervals for a population mean. Remember that previously we learned if we have population proportion as our goal of finding all estimation of population proportion, we use confidence interval. First of all, we need a point estimate, p hat, point estimate, which was our sample proportion. Sample proportion. Well, after finding our point estimate or the sample proportion, we were interested in finding the margin of error. So margin of error was equal to, when we are dealing with 95% confidence interval, 1.96 times the standard error, which was p hat, 1 minus p hat divided by n. Then our confidence interval was equal to p hat minus margin of error, comma p hat plus margin of error. This is what we learned before. Well, now we're interested in finding the confidence interval for population mean. Remember that population mean is denoted by Greek letter mu, like the sound of a cat. Population proportion was denoted by P. So P, population proportion. Now in this lecture, we're going to talk about confidence interval for a population mean or mu. Well, okay, let's begin. We need some information, some background to build up our formula. Very well. Introduction. Commute time is the amount of time it takes to travel from one place to the other. For example, the time it takes for students at your college to get from their homes to school. Of course, note that our class is online right now, so the commute time is from the bed to the desk, or sometimes students are sitting on their bed, so 0 time for commute. Well, I was back in the time that we had face-to-face classes, and it was related to that time when students take the bus, take the car, take the bike to get to the school. Think about the mean commute time of students at your college. Do you think it's longer than a half hour? Is it less than an hour? Do you think it's similar to the mean commute time for students in your class? So think about it this way. We are asking questions about students in college and asking questions about students in class. College as a population is much more larger than the class, which is just a sample in our population. In this lesson, we're beginning the process of making inferences about the mean of population. Again, remember that the mean of population denoted by mu, we use the t-distribution. Why is that? Why? The reason is we don't have information about college. Remember, to gather information about population, we need money, we need resources, we need to spend time, which is not realistic. But gathering information about class is much more realistic. Well, remember, we use t-distribution when the standard deviation of population is not given. T-distribution. We work with sample standard deviation. Sample standard deviation. Very well. Okay, let us continue. We use t-distribution to compute margins of error and confidence intervals for a population mean. With what we learned using the t-distribution, we will make inferences regarding the mean commute time for students at the college. Okay, let us begin. What do we have here? Understanding t-distribution critical values. Remember last time you asked me, hey, why you are using 1.96? Is this fixed? Remember I told you when we are dealing with 95% confidence level, we use 1.96 and the name of 1.96 is critical value. In this lesson, we're going to talk about the rest of the critical values. As we change the confidence level, the critical value is changing. In previous modules, we computed confidence intervals for population proportion using sample statistics and critical values. Since we didn't know the population proportion P, the margin of error in a sample proportion P hat was computed using the formula E equals to 1.96 square root of P hat 1 minus P hat divided by N for 95% confidence level. This is what we saw before. Remember that the margin of error is equal to a Z as critical value, which in this case is 1.96. Z critical value. ZC is the symbol that we're using for critical value, multiplied by the estimated standard error for sample proportions. Standard error was square root of P hat 1 minus P hat divided by N. Well, the sample proportion is a point estimate. Sample proportion denoted by P hat is a point estimate. The resulting confidence interval, an interval estimate, is P hat minus E, comma, P hat plus E, and we put this in parentheses. This is our confidence interval. This is what we learned before. It was about population proportion. Now we are using sample mean to estimate population mean. This is our goal in this class. In this session, we're going to talk about population mean. We use sample means. Sample means. How do we represent sample means? Sample means are denoted by X bar. So point estimate for population mean is sample mean, which is denoted by X bar. So sample proportions, P hat, sample means, X bar. To estimate a population mean. Notice that in the formula below, we are now using S to estimate sigma. What was S? S is sample, standard deviation, and sigma is population, standard deviation. Remember our formula? Our variable t is equal to x bar minus mu divided by s over square root of n. Sometimes we just write it as x bar minus mu times square root of n. So I take the second denominator and write it on the numerator, divide everything by s. This is our t. Well, the test statistic varies according to the t distribution with degrees of freedom, which was equal to n minus 1. To compute the margin of error in a sample mean, we multiply a t critical value, not z, by the estimated standard error for sample means, which is s divided by square root of n. Okay, well, here we go. The margin of error in a sample mean is given by E equals to T sub C S over square root of N. This is the margin of error when we are estimating population mean. Again, remember that for population proportion, the margin of error was ZC, the critical value 1.96 times square root of p hat 1 minus p hat divided by n. This is for population mean. So the sample mean is the point estimate for the population mean. The resulting confidence interval for population mean is x bar minus e, comma, x bar plus e. Again, remember that for population proportion, confidence interval is p hat minus e, p hat plus e. So when you're solving a problem, you need to first identify if the question is asking about confidence interval for population proportion, or is it asking about population mean? If it's asking about population proportion, you're going to follow the steps that you learned before on the right-hand side. If the question says, hey, estimate population mean, you're going to follow what we're going to learn today. Another way to write the confidence interval for a population mean is x bar plus minus e. Well, we're going to learn how to find t sub c. There are several important things to remember about t distribution. The proportion of the t distribution contained between the critical value t sub c and its opposite, which is equal to the confidence level. The t distribution varies with degrees of freedom. Again, recall that degrees of freedom is n minus 1. T critical values depend on both the confidence level and degrees of freedom. Below, you will find a partial table of t distribution critical values. When we use the table or technology, our calculator, It is possible to find T critical values for different combinations of confidence levels and degrees of freedom. So when you're solving your homework problems on the exam, you can use T distribution, T table, critical values for the T distribution based on the confidence interval and the degrees of freedom. We have different critical values. So note that you need to identify the confidence level, and also you need to identify the degrees of freedom. For example, if a question says, well, I have confidence level 95% and the degrees of freedom n-1 is equal to 9, you quickly say, hey, the critical value is 2.26. If the question says, hey, the confidence level is 90% and the degrees of freedom is 4, it means that the critical value is 2.13 and so on. So if you need a better T-table, you can Google T-table, and the very first table, which is from our university, you click on that, includes more critical values for a T distribution. So here we have this table as well, based on the confidence level, 0%, 50% to 99.9%. And the degrees of freedom, you can find more critical values here in this table. So let's see what do we have here. Let us continue. Try this. The questions below are designed to help you think about the relationships between degrees of freedom, margins of error in confidence intervals, sample size, confidence intervals, precision of confidence intervals, critical values, and confidence intervals. Well, okay. To answer the questions, use the margin of error formula and the T distribution table that we saw. 1. For a given confidence level, like 50%, 80%, 90%, 95%, as the degrees of freedom increases, what happens to the critical value? So take a look at this. It says, as the degrees of freedom increases, what happens to the critical value? Our degrees of freedom, this is the smallest degrees of freedom that we have, which is 1. So as you can see, the critical values 6, 12, 31, 63. We increase the degrees of freedom by 1 unit. Now the degrees of freedom is getting larger to 2. Well, as you can see, the critical value is now 2.93, 4.30, 6.97, 9.93. Let us pick another number. A degrees of freedom which is getting larger, like 10. As you can see, the critical values are all getting smaller. So the answer to the question is, they are getting smaller. Okay. For a given confidence level, as the degrees of freedom increase, what happens to the margin of error? Okay, margin of error. What is increasing? The degrees of freedom. They are getting larger and larger. What happens to the margin of error? So remember the formula for margin of error. Margin of error is the critical value times S over square root of N. So the degrees of freedom increases. We know that critical values are getting smaller. Critical values are getting smaller. So the margin of error is also getting smaller. So they are getting smaller and smaller. Again, as the degrees of freedom increases, critical value is getting smaller. And since the critical value and the margin of error are proportional together, as TC is getting smaller, your margin of error is also getting smaller. Larger degrees of freedom result from larger sample sizes. What does this imply about the relationship between the sample size and the precision of confidence interval? So remember that as the confidence interval is getting smaller, we capture the true population parameter. As the confidence interval gets smaller, we capture the true population parameter. So it gets more precise. It is more accurate. 4, for given degrees of freedom, what happens to the critical values as the confidence level increases? Okay, as the confidence level increases, the critical values, take a look at this. As the confidence level increases, the critical values are getting larger. When the confidence level is 90%, we have 6.31 as the critical value. When the confidence level is 95%, the critical value is 12.71, which is greater than 6.31. As the confidence level is now 98%, the critical value is 31.82, which is larger than these two. And as the confidence level is 99%, the critical value is so huge. It is 63.66. So the answer is they get larger. The critical values get larger. So as the confidence level increases, the critical values get larger. 5, for given degrees of freedom, suppose we have a degrees of freedom, n-1, what happens to the margin of error in the confidence interval as the confidence level increases? So, you know, E, or margin of error, is equal to TC times S divided by square root of N. Degrees of freedom is given to us. What happens to E as the confidence level increases. Remember that confidence level increases, it means that critical value increases. When the critical value increases, since it's proportional to margin of error, it gets larger. Since the critical value, TC, gets larger, E, or the margin of error, gets larger as well. So what is our conclusion here? What do your answers imply about the relationship between the confidence level and the precision of confidence interval? So as the confidence level increases, so 90%, 95%, 98%, 99%. So as those percentages get larger and larger, we saw that the confidence interval gets wider, not narrower, so we get less precision. Result in less precision. Remember that we need to capture the true population parameter. As long as your confidence interval is wide, it means that it doesn't capture the true population parameter. Very well. So let's go over some examples. Try these. How long did it take to get here? What is the average commute time for students at your college? This may not seem very important, but for the administration and staff who schedule classes and plan activities, travel time is an important factor. Using sample data from your small group, compute a 95% confidence interval for the mean commute time. Assume the commute times at your college are normally distributed. Note, this assumption about the population allows us to conclude that the distribution of sample means is normal and enables us to compute confidence intervals using sample sizes less than 30. Well, list the commute times in your sample in minutes. Here's an example data table to get you started. Okay, guys, I need your participation here. So before everything goes online, what was your commute time? So I need 3 answers: student A, student B, and student C. Please write it in minutes. How many minutes it took you to get to your school before everything went online? $10 minutes, 20 minutes, and 10, 20, and one more. And 50 minutes. Thank you. Very well. Question 8 says, determine the sample mean. So remember that our goal is to find confidence interval for population mean. So our point estimate is now sample mean. We need to find X bar. Then we need to find sample standard deviation and sample size of your sample. Very well. So let's use our calculator. Turn on the calculator. Erase this. So let's go to Stat, go to Edit, and I'm going to delete this. Okay. So 10 minutes, 20 minutes, and we have 15 minutes. Very well. So go to Stat, go to Calc, one variable, and then since everything is in L1, you can calculate the mean, which is 26.66, and the standard deviation is 20.82. This is 20.82, and the sample size N is equal to 3. We only have 3 numbers here. Question says, well, now determine the critical value T sub C that corresponds to 95% confidence level. Before finding this critical value, we need the degrees of freedom. Degrees of freedom is N minus 1, N is 3, so we get 3 minus 1 or 2. Well, okay, the confidence level is 95%, degrees of freedom is 2. Let us take a look at our table. Degrees of freedom is 2, and then the confidence level is 95. So as you can see, the critical value is 4.30. So TC is 4.30. We found the critical value. And the next step, question says, now that you have all of the information, compute the margin of error. Remember that the formula for margin of error for the mean is E equals to critical value T sub C times S divided by square root of N. T sub C, we know by using our table, is 4.30 times S. S, we used our calculator to find S, 20.82. Divided by square root of N, N or the sample size is equal to 3. Okay, let's use our calculator to compute this. So let me clear this. What do we have? 4.30 times 20.82. Now I'm going to divide this by square root of 3, which is 51.69. 51.69. Now question says, construct the 95% confidence interval. Confidence interval is X bar minus E and X bar plus E. So X bar is just 26.66 minus the margin of error that we calculated, 51.69, 51.69, and X bar plus E, 26.66 plus 51.69. So approximately, what do we have? we have approximately, we have 78, comma, approximately, oh, this is 78 goes here. And here we have a negative number. Which is not that realistic. Negative 26 to 78. So it means that some students are already living close by the university. So this negative number is not very realistic, but 78 minutes it takes for some students to get to the school in 78 minutes. So the population parameter is a number in between these two. As you can see, the negative number is not realistic. So where did it come from? It came from our sample being very small. So remember that as a statistician, you need to collect enough data, not just 3 numbers. 3 in a sample is very small. So as you can see, it results in an unrealistic information. So make sure as a statistician, you collect enough data and you construct a confidence interval that actually gives you realistic numbers. So interpret your confidence interval. What does the confidence interval say about the commute time for all students in your college? We can say that we are 95% confident that the mean commute time for all students in our school is between negative 26 minutes, which is not realistic, and 78 minutes. So again, to make sure we have realistic numbers, numbers that make sense, we need to collect more information. Okay, so let us see how we can use our calculator to find the confidence interval. I'm going to put my calculator here so you can see all of the calculations. So suppose you want to use your calculator to find the confidence interval for the data that we collected here. So far, we used everything using the paper and pencil to calculate everything using the formulas. Now we're going to see how technology calculates everything much more faster, much more accurate. So confidence interval for population mean. So what are we going to do? First, we're going to go to Stat, Edit, enter the numbers. So Stat, Edit, enter the numbers in L1. So I'm using L1 here in this case, in our example here. Then you're going to go to Stat, and then you need to go to Tests. So Stat and Tests. So in tests, you need to find not the interval, but T interval. So T interval gives you the confidence interval for T distribution. So T interval. Okay, here we have the data. We have 10, 20, 50, and we already entered them in L1. So keep it as data. List is in L1. If the question says, hey, 95% confidence level, you leave it as 95% confidence level. If it says 99, you're going to enter 99. If it's 90, you're going to enter 90 and so on. Then click on calculate. When you click on calculate, the very first interval is your confidence interval. So as you can see, the confidence interval is approximately minus 25.04, 25.04, comma, 78.38, 78.38. So this is our confidence interval, which is very close to what we calculated before, negative 26, comma, 78. This is what we calculated using our formulas. This is what our calculator calculates for us.